For example 2, you're going to be asked to determine whether or not the statements or the argument you're presented with is valid or invalid, and base that off of how well it lines up with the standard forms of arguments that you were given in the yellow box out of your reading. So you're asked here if the following is a valid argument or invalid. And one of my underlines is already showing up before I wanted it to, but that's okay. If you read the Riptide Ultra Glide, then you can understand Tiger Shrimp Tango. You cannot understand Tiger Shrimp Tango, therefore you did not read the Riptide Ultra Glide. So, these two original statements, this if-then statement and this statement up here, are basically the two conditions. What we're assuming to be true, and we want to say that this is a natural consequence of these two statements both being true. So I need to first translate this into some statements I could make use of. I'm going to use a lot of P's and Q's because that's what they tend to use a lot in the book material. However, you could use any letters that you want as long as you know what they stand for, and therefore, you don't get anything mixed up. So I'm going to let reading Riptide Ultra Glide be P and understanding Tiger Shrimp Tango being Q, which means that this first statement up here is if P then Q, or P arrow Q if you want to look at it that way. The second one is you cannot understand Tiger Shrimp Tango. So you can see that Q is understanding it, therefore not understanding or not being able to understand it's going to be a not Q. So these are the two conditions we have. We want to say therefore as a result, you're not going to, that means you did not read Riptide Ultra Glide. So now as you look at this, and you're supposed to use the laws that you've been presented with, as you can see, this exactly mirrors the law of contraposition. Therefore, if you look at this, since it's mirroring this law, I don't need a truth table because, this has already been proven with a truth table. This particular law is following this exactly, which is the other reason why I'm using P and Q is my letters, because that's the letters that are using in this rule. So based off of this, this would be a valid argument. For the next one, the printer has a clogged nozzle, or the printer does not have toner. The printer does have toner, therefore the printer has a clogged nozzle. So again, we have these two premises. The printer, so we're told that maybe you're working on the printer and it's having an error that based on what you're seeing, you make a statement. It either has a clogged nozzle or it doesn't have toner, because maybe it's just not printing. And then you check and say, okay, well, the printer does have toner, therefore it has to have a clogged nozzle. Is this a valid argument? So again, I'm going to look at P being the printer has a clogged nozzle. There's an or statement here. The printer does not have toner. I'm going to let Q be it having toner, or put it this way. Even though it says does not, I'm going to let Q represent that the printer does not have toner. And the reason why I want to do that is because I'm trying to make it fit one of these laws that you have listed. And the laws you have listed don't really have any of them where the first statement has a not statement being in there. So for this first one here, based off of this, I'm going to say this is P or Q, because I'm defining Q as it not having toner. Therefore, when I say the printer has toner, it's perfectly legal to say, well, if Q represents it not having toner, then the opposite of that, or not having toner, would be having toner. Therefore, I could make this, symbolize this as not Q. Therefore, the printer has a clogged nozzle. Therefore, we're going to say therefore P has to be true. So, basically if I know that there's two possibilities for an issue or two things happening, and I verify that the one hasn't happened, but I know that one or the other has to happen, therefore the other one, the one of them has to occur. So this is basically, it's very similar to the distinctive syllogism. The only thing that's different here is notice that we have P or Q. The other thing that's different here is I'm saying not Q, then P. I mean, that works just the same way as me saying if not P, then Q. It's basically saying if one or the other has to occur, and I verify that one of them does not occur, then the other one has to occur. So even though I have different letters here, based off of this, if I wanted to make it match exactly, all I would have to have done is call this Q, call this P, and this would have been not P by result, and I would have the exact same setup here because this would have been not this would have been Q. So, no big deal about the letter designations here so much. It does follow the disjunctive syllogism, so it is a valid argument. The next one. If the car is new, then it has air conditioning. The car has air conditioning, therefore the car is new. The thing is about this is, we know if the car is new, then it has air conditioning. If the car has air conditioning, if the conclusion is valid, does that mean the original that the if part had to have been, true or not? Is that a lot of people think that's a valid argument in that way, but it isn't. You're going to see here the car is new. So if P, so I'm going to P the car being new, Q being it has air conditioning. So if P then Q, the car has air conditioning, so that's Q again. The argument's being made, therefore P has to happen. Well, this is basically, you're kind of dealing with the converse here. You're basically saying, well, if P then Q, then if Q happens, then P had to have happened. That's not necessarily the case. By the fallacy of the converse, and if you do a truth table, you can prove that this does not work for some instances, therefore it's a fallacy. Since it's a fallacy, it's not a valid argument. So, so a lot of people think it is in situations like this, but it isn't. So always be willing to either see if it fits this particular rule or use a truth table to verify it. The next one. If I can get Elizabeth to dance class by 4:30 p.m., then I could go shopping. If I go shopping, then we do not have to order pizza again. Therefore, if I can get Elizabeth to dance class by 4:30 p.m., we do not have to order pizza again. So, letting P being getting Elizabeth to dance class by 4:30 and Q being me going shopping, the first statement is if P, then Q. If I go shopping, then we don't have to order pizza. So going shopping again is going to be Q, and R is another statement, so this is going to be if Q, then R. Therefore, if I assume P, then R is going to happen as a result. Is this a valid argument? Well, by the law of syllogism, it is. And we actually had done, one of the previous example, we actually had proven this law using a truth table. So, with that along with it, we know this is a valid argument as well. And the last example, if Wendy completes her project on time, she will pass her history course. Wendy does not complete her project on time. Therefore, Wendy does not pass her history course. So, to see if this is a valid argument, I'm going to let P represent Wendy completing her project on time, and Q being that she passes the history course. Well, this next statement says, well, she does not complete her project on time, which is the exact opposite of completing it on time. Therefore, this would be not P. So we're basically saying, okay, if P then Q, if P doesn't happen, does that mean automatically that Q is not going to happen? Is that a valid argument? Well, I mean, the truth table can be shown for it, but this is the fallacy of the inverse says, okay, well, if I have that kind of setup, that's a fallacy. This is not a true statement. Therefore, this is not a valid argument. Now, again, are you going to be required to know these fallacies and rules? No, you don't have to. You're not. I mean, in some cases, they might ask you a question or two, saying that is it true by this law or true by that law. But most of the time, you're just going to be asked, is this a valid argument or is this not a valid argument? And if that's what you're asked, then, if you recognize it's a law of syllogism or it's a fallacy of the converse or inverse or whatever the case may be, then by all means you can make use of that. You just want to show that, that one, that you're showing that you can translate the statements, and two, that you know what the fallacy of the inverse is. Um, so making sure to put that statement in there so that we can be verified, that's fine. If you just want to use a truth table, which in some cases might just be easier than trying to memorize this stuff, then by all means use the truth table. It's just, I mean, that's what ultimately proves these things anyway. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.